All right, so here are some answers to um, a worksheet that you're working on just a minute ago. And so first, I should have had this set up before, but let's talk about the x-intercepts of the graph. So when will this parametric function hit the x-axis? And of course, it'll hit the x-axis when the y-coordinate is 0. And of course, we already saw when t is 0, then the y-coordinate is 0. And so when t equals 0. When else? Well, t is never going to be 0 again, but whenever sine of t is 0. And so when t is pi, from our unit circle, we know 2 pi, 3 pi, and of course we could go negative time, we could go negative pi, negative 2 pi, and so forth. And so basically it's any multiple of pi. And where will the x coordinates be? Well, it'll just sort of flip back and forth, right? Cosine of pi is -1, cosine of 2 pi is +1, and then t will be t. And so we should be seeing lots of x-intercepts, right? So like at negative pi, we should see one at 2 pi, and so forth. And when I look at this on Desmos, it's sort of nice to see an animation. We can sort of see time going on. And so as time goes forward, we see it plotting the points, and we're sort of thinking of this particle moving. And so here's an x-intercept at around t being pi. And then we keep going. Here's another one at 2 pi, and keeps going. This one would be over here at about -3 pi. So sort of a nice animation of that graph. Okay. When we get to number 4, we're looking at x being 2t and y being t squared. And here's the graph on Desmos. And of course it looks like a parabola. Maybe not super surprising. And when I go back to the worksheet and find dx dt, and so now when we're taking derivatives, we have to be really careful about what variable we're taking the derivative with respect to. So dx dt, that's just the derivative of 2t, and so dx dt is 2. dy dt then would be 2t. And so what do these tell me about the graph? Well, it tells me how the x and y coordinates are changing with respect to time. And so the x coordinate is just always changing in a constant of 2 units of distance per unit of time, right? The y coordinate is changing faster as time goes on, basically, right? So as time gets bigger, dy dt gets faster. We're not going to do this a lot, but it'll be a nice setup for our next set of notes here. And so x of t equals 2t, y of t equals t squared. And so what we can do is we can solve this first equation for t. And I'll stop writing the parentheses with the function notation, but t is basically x over 2. And if I now take this and plug it in there, y of t then, or y of x once we substitute, will be t squared, and so it's x over 2 squared, which is x squared over 4. And sort of the nice thing about Desmos is I can graph both formats at the same time. And so if I graph y squared over 4, I see that I'm getting that exact same graph. And of course the red graph does stop because I only did some t values, but it would keep following this parabola if I kept going on that. And so now I can say, well, what's dy dx for this equation? Well, that's just good old derivative. And so dy dx here would be 2x over 4, also known as x over 2. And the question is going to be, how does this derivative relate to our derivatives with respect to t that we took in the previous problem? And we will see that in the next video.